Sleeping Monday. What I want to do right now is have you go back to page 50. So if you open your books, we are going to go back into the reviews. Today I'm going to focus on the chapter 1 review, go through examples of each of the types of questions that you can do with 1 and 2. And today's Tuesday, probably by Thursday, if we work on chapter 1, I will get a little assignment out for you Thursday to go back through this chapter. You can hand it in and we can make some mark adjustments with it. Okay, so I'm going to go through each part of this right now. Okay, hopefully you can see the board just fine. If you can't, then let me know. All right, so page 50. So the first thing that we're going to look at is arithmetic sequences. So an arithmetic sequence. Oh, come on. Lovely. Okay. This first. This second. All right. So we're going to try this again. I'm going to have to reset everything. Sorry. Okay, so do some fancy footwork here. I'm going to put it over here. Hopefully you can. Oh, just a second. Might be too close. Okay, I don't know how close it is. That's fairly close. Anyways, this will work till now for now. Okay, so what I want to do right now is arithmetic sequence would be. Oh my good gracious. One of these has to work. There we go. 1, 3, 5, 7, 9. Now that's considered an arithmetic sequence. Okay, and I know that's probably very hard for you to see. So arithmetic sequence means that you have a term 1, in this case is 1, a common difference, which is 2. So I go from term 1 to term 2 to term 3 to term 4 by adding 2 to each of the terms. So I have what we call a common difference. So I add the common difference to get it to the next term. All right. To find any one term, I gave you this expression here. Okay, t to the n equals. You all right, Tessa? Yeah. Okay. So I've got t to the n equals t to the 1 plus n minus 1 times d. So if I wanted to find the 15th term of this, I go t to the 15 equals t to the 1, which is 1, plus 14 times 2. Okay, t to the 15, the 15th term is 1 plus 28, which is 29. So this is what we call an arithmetic sequence. Let me see if I get this going here. Still don't know if this is going to work. Sorry, I'm going to play at the board for a second here. I guess it's not working. Okay. Once that opens up, we'll get going again on it. Sorry. Okay. So that's the first thing that we did is we worked with arithmetic sequence. The general term for an arithmetic sequence. This is the one thing that we had to get better at. I have t to the n equals. I have to have a value for 1, for t to the 1.
Mr. Newton, someone muted you.
Oh, okay. There we go. Sorry about that. Okay, so I was talking about the general term for this. So the general term for this, okay, t to the 1 plus n minus 1 times d. I need a value for t to the 1 and I need a value for d. So I put it in like this. And then what we did is we actually solved this a little bit. So I get t to the 1 equals 1 plus 2 to the n minus 2 equals 2 to the n minus 1. So the general term to find any one value in this arithmetic sequence, I do it by taking 2 and I subtract 1. Okay? Close that. There we go. All right, I'm back on the board. Sorry for the problems this morning. A long weekend for my technology, apparently. Okay. I think I got the board there, do I not? See the whole board? Okay. All right. So back to business here. Okay, so after an arithmetic sequence, one of the questions that they'd ask is, okay, determine the first term, the common difference of the arithmetic sequence given the following terms. So I'm looking at question 3D on page 50. So I have t to the 7, or actually I want to put the other term first. So I have t to the 7 is 37. T to the 10 is 22. All right, and I need to find my term 1 and my term and my common difference. So I start by going like this. T to the n equals t to the 1 plus n minus. All right, there's my general statement. Now what I'm going to do is I'm going to go 22 equals t to the 1 plus, because it's t to the 10, I'm going to make that 9d. Then my next one is going to be 37 equals t to the 1 plus 6d. Okay, so all I've done is I've substituted in t to the 1 and n, and then whatever the value was here. So t to the 10 was 22, n is 10, that means that that's 9d. And now what I'm going to do is I'm going to subtract the 2. So I subtract it. That gives me minus 15. T to the 1 minus t to the 1 is 0, equals 3d. D is equal to negative 5. All right, so again, this is just linear expressions that we've worked with. All right, use the elimination method because t to the 1 is always going to be having a coefficient of 1 in front of it. All right, then I go down here and I can use one of the terms. So t to the 7 was 37. That equals t to the 1 plus 6 times negative 5. Okay, so I just substituted into this equation. T to the 1 I don't know. I'm going to solve for it. N is 7, so that's 7 minus 1, which is 6. D we solve for is negative 5. That becomes negative 30. Negative 30 add to the other side is now 30. I get 67 equals t to the 1. Okay? And we haven't done this since the start of the year, so I suspect that there will be some issues. But I'm going to go through the whole thing fairly quickly, just as a review for you. So if there's somewhere you want me to stop along the way, just let me know. Okay? Now, the next thing that we did was an arithmetic series. So the difference between a sequence and a series is just the sequence of numbers. A series is you add those numbers together to get your term. One of the things that I did not do and I should have done, maybe. I'm just going to write it down for my own benefit right now. And that is, you have a formula sheet that was given to you at some point at the start of the year, And on that formula sheet, they gave you, for the sum of an arithmetic sequence, they gave you two equations. So s to the n, n over 2, 2t to the 1, plus n minus 1 times d. Okay, and then the other one is s to the n equals n over 2. And if you know the nth term, you can find it that way. Okay, so just to look at the very first example on 1.2, so page 51, 6a. So term 1 is 6. Term 2 is, oh sorry, term 1 is 2, my bad. Term 2 is 8, and term 3 is 14. Okay, so the first thing that I should do in this question, first thing I might want to do is find out what my common difference is. So I start with my D. So to find my common difference, I take the second term and I subtract the first term. Or I take the third term and I subtract the second term, whichever. So 8 minus 2 is 6, 14 minus 8 is 6. I know my common difference is 6. Okay? Now, to find the sum of those first three terms. S to the 1. So the first sum is 2. S to the 2. The second sum now is 10. And then I have S to the 3, which is 24. So I started with the first value, which is 2, and then I add the second value to it. So 2 and 8 make 10. 10 and 14 make 24. Okay? 24 and S to the 4 would be, add 6 to it, would be 20. S to the 4 would be 44. So I could keep it going. So my fourth term is 14 plus 6, which is 20. 24, excuse me, 24 plus 20, S to the 4, 44. So an arithmetic series is when I add all of my terms together as I go through a sequence. Okay? All right, if there's no questions about that, these are the two equations that I use for an arithmetic series. Okay, I'm going to look at a geometric sequence now. So again, because I'm implying sequence, that simply means then that I want to go just the values. And in this case, I multiply by a common ratio. So an example, I'll look at the first example here. I'll look at question 11a. So 11a. So I've got 3, 6, 12. All the way to 256. Oh no, my bad, 1536, not even close. Okay, so I have that. So in an arithmetic, or sorry, in a geometric series sequence, not series sequence, in a geometric sequence, I have my first term again. And now I need a common ratio. To get my common ratio, I take the second term, I divide it by the first term. Or I take the third term and I divide it by the second term. So 12 divided by 6, 6 divided by 3, that means my common ratio is 2. So to calculate any term of this geometric sequence, I use that equation there. T to the 1 times r to the n minus 1. So if I were wanting to find out what term 1536 was, I go 1536 equals t to the 1, which is 3, times 2 to the n minus 1. So I take 1536 and I divide it by 3 to begin with. Now I hit a bit of a roadblock because the unknown variable is in the exponent. Now, thankfully, in grade 11, all we have to be able to do is get a common base, and then we solve with the exponents. So 512 must be 2 to the power of something. Okay, so 2 to the power of 5 is 32, 6 is 64, 7 is 128, 8 is 2, so this I think is 9. I think it's, I have to look, but I think it's 2 to the power of 9. Yeah. Okay, so I have 2 to the power of 9. So the 10th term of this sequence, geometric sequence, is 1536. Okay. Again, it's going to go through real quick just because we've done it. It's a bit of a review for us. Let's look at 13. A. Question says, given the two terms of each geometric sequence, find the general term for the sequence. Okay, so the general term of the sequence, t to the n equals t to the 1 times r n minus 1. So I need a value for t to the 1 and I need a value for r. So t to the 1, we don't know, but we know t to the 3 is 36. And t to the 4 is 108. So the first thing I want to do is, I can't find my t to the 1 right away, but I can find my r, because I multiply t to the 3 by something to get to t to the 4. So if I divide 108 by 36, I get my ratio, which is 3. So now I go t to the 3, which is 36, equals t to the 1 times 3. And because it's the third term, that makes this a 2 up here. So 3 squared. 36 divided by 9. T to the 1 is equal to 4. So I've got t to the 1, I've got r equals 3. My general term for this is 4 times 3 n minus 1. And there's my solution. So that takes care of geometric sequences.
I have a question about that one.
Go ahead.
I'm just wondering where you got like the squared on the 3, like when you put 3 squared up there.
Okay. 36 is the third term, right?
Yeah.
That means that n is 3. So 3 subtract 1 makes 2.
Oh, okay. That makes sense now.
Okay? So whatever the term
Yeah.
value is, I'm sweaty here. Whatever this term value is here, whatever that term value is, that's what your n value is right there. Okay? Waiting. All right. Any other questions about this so far? Everybody's okay? You good, Paige?
Yeah, thanks.
No problem. Okay, so the last thing that we need to do is, well, two things actually, is find the sum of a finite series and find the sum of an infinite geometric series. I'm just going to go back, find my equations. All right, so the sum for a finite, meaning a series in which I know the ending value. Okay, so a finite, if you recall, that's a geometric series in which we know the ending. That means that my value for my r has to be greater than 1. Okay? For an infinite geometric series, I have s to the n equals t to the 1 over 1 minus r. And in this one, my r value has to be a fraction, either a positive fraction or a negative fraction. It doesn't matter. It has to be one or the other. Okay? So it has to be, and remember when we talked about this, we used two words. We used the word convergent and divergent. Convergent means that it's coming towards one particular value. Divergent means it's going away and keeps getting bigger forever. So I'm going to focus on this infinite for 1 second here. So an example of this would be 16, 8, 4, 2, and so on. So I have an infinite geometric series here. My first term is 16. My common ratio is 1/2. So that falls between -1 and 1, which means that my sum is going to converge, which means come together towards one particular value. So 16 over 1 minus 1/2, which is 16 over 1/2, which means it's equal to 32. So the sum of all of these values, as they keep getting smaller and smaller and smaller, the sum is going to get closer and closer to 32, but never really get there. So have a look right now. S to the 1, 16. S to the 2, using that, is 24. S to the 3, using the 4, is 28. S to the 4, using the 2, is 30. S to the 5 would be 31. S to the 6 would be 31.5. And so it would continue to get larger here, approaching 32, but never actually hit it. That's what we call a convergent geometric infinite series. And that's because my r value is between -1 and 1. If my r value is a fraction, it's going to converge towards that right there. All right. And then they give you examples of a finite series. So look at question 15a. It has 24, -12, add 6, and so on until we get to the 10th term. And they want us to find the sum of the first 10 terms. So in order to find the sum of the first 10 terms, the first thing I need is a T1, which I have is 24. The second thing I need is my R value, which in this case is -1/2. All right, so I want to find S to the 10 equals. Just go back a page. I'll use this equation right here. So T to the 1, R to the n -1. I'm just going to make this a little bit smaller for a second. So I've got R, which is -1/2. Nope, sorry. Let me just rewrite this out. So T to the 1, R to the n -1 over R -1. Okay, so S to the 10 is equal to T to the 1, 24. R is -1/2. That's to the 10, subtract 1 over R, which is -1/2, subtract 1. So at that point, you're probably using your calculator to calculate that. So 24 times 5 to the 10, subtract 1, bracket divided by bracket. At 15.984. Okay, so punching that into my calculator, I had 24. Open the bracket for the top. I have negative 0.5 in brackets to the power of 10. Subtract 1, close the bracket. Open another bracket for down here. And that's negative 1.5 down to the bottom. And this is what I get here. So that is a finite geometric series in which I am finding out what the totals of those are. Now, let's say hypothetically that I struggled with this. I didn't like this. I had a hard time getting to where I needed to get to here. So how about we write out the 10 terms and then we simply solve it that way. So let's do that. So I've got 24 minus 12 plus 6 minus 3 plus 3 over 2 minus 3 over 4 plus 3 over 8 minus 3 over 16 plus 3 over 32. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 terms. So I would have those as my 10 terms. I'm sorry they're so small, but I wanted to write them in. And then I could just simply put that into my calculator as well. So let's do that so that I can see that I got the right answer. So I go 24 minus 12 plus 6, subtract 3, plus 3 divided by 2, subtract 3 divided by 4, plus 3 divided by 8, minus 3 divided by 16, plus 3 divided by 32, subtract 3 divided by 64, and I end up with the exact same solution. So sometimes the easiest thing that you could do to make your life easier, if you only got 10 or 12 or maybe even 15 terms, is to write out all the terms and then solve it. And you should end up with the same solution in both cases. 15.984. All right. Okay. So what I'd like for you to do is go through that whole chapter 1 in review today and tomorrow. And then I will get you an assignment for Thursday on chapter 1 that we can do Thursday, Friday. And then Monday I'll start in on chapter 2. And what we'll do is we'll just try and get some of these marks better than what we were from the first time around. Questions, comments, concerns? Okay, so if you have not got your assignment in from last week, that would be the first thing I'd like to see you do right now is work on that and get it done. And then if you are done with that, then I want you to work on this chapter 1 review and expect to get an assignment in 2 days where we will try and improve on that mark that you got the first time around. Okay, I will leave you up and on here for the next 15 or so minutes if you want to talk or ask questions. Let's do it that way. Okay? All right, just going to put you on mute. You guys can communicate.